So now, what would change? I really don't want to draw the other picture. If you want me to, I will. What would change if b were between 0 and 1? How would the picture of logarithm change if the base were a proper fraction? If the base were between 0 and 1, if it were a proper fraction, it would look like that. It would look like the reflection of this one over the x-axis. Okay? I should have drawn the whole picture, shouldn't I?
Is that the derivative?
No derivative. We haven't even talked about derivative yet. I mentioned the exponential derivative of log. We have not said anything. Just getting the picture of log right now. Okay? And its domain is important. The domain of log is important. Just 0 to infinity. No negatives. No zeros. No zeros, no negatives. Are you okay with the last part?
What was the last part you said?
That if it wasn't log 2, what was log 1/2, log base 1/2, what would the graph look like? It would now look like the red graph. It would be a decreasing function as opposed to an increasing function. All the rest of the structure is the same though. Same asymptote, same x-intercept, everything else is fine. Okay? Justin, that all right? Now the derivative of logarithm. Derivative of log base b of x. Without any derivation, I'll simply tell you, just like I did with the exponential, the derivative of log base bx is 1 over x. It's the reciprocal function, except it requires a compensatory factor. What do you think the compensatory factor is? What's that? What was it last time? ln b. ln b down here. Okay. There's our compensatory factor. But the core of it is 1 on x. Okay. It has an extra little constant attached down at the bottom. Okay. Just like the core of the derivative exponential is the exponential back again, right? But it has that compensatory factor, ln b. So to a general logarithm. So now what happens if you don't have a general logarithm, you have the natural logarithm specifically, right? So then if you use ln x, what does ln x mean?
Natural log.
Natural log. So what base is it?
10.
What do you say?
10.
That's common.
E?
What do you say?
E?
E. This is a short notation for logarithm base e of x. That's what it's short for. Okay? Log natural, ln. But Justin has mentioned the common logarithm, so we'll write it as well. It's so common, we don't write the 10 with it. So you just use, when you say log x, you mean log base 10. When you say ln, you mean log base e. That's what these things mean. Okay? So for these particular cases, let's take the log base 10, since Justin mentioned common and natural. All right. So if I want the derivative of log base 10, I want d dx of log x. That's going to be 1 over the natural log of 10 times x, correct? Just the natural log of the base goes down, and the base is 10 for the common log, so therefore 1 over ln 10x.
And so why is it 1 over natural log?
Now what?
I'm just going by the formula. I did not tell you why
Oh.
this is. I did not show you any particular derivation of why this is the case. I'm just stating it as a fact.
Oh, okay, that's
And they're just applying the pieces into the formula. So now about ln x. If I take the derivative of ln x, the natural logarithm, whose base is e, then its derivative is going to look like 1 over the natural log of e, because that's the base, x. What's the natural log of e? 1. So therefore, what's the derivative of the natural log? 1 over x. Okay? So that's why I was saying that's kind of like the core derivative for logs. And anything that's not the natural log needs a compensatory factor called ln of the base put in the bottom. Okay? You see what I'm saying? 1 over x for the natural log, and everything else which is not natural right, is 1 over x, but it has that little number attached on there, ln of its base. All right, so there's our two new rules: derivative of every exponential function now, and derivative of every logarithm now. And I want to go ahead. There's more to this section, but I want to try a few problems first. We're ready to talk about the other stuff in this section. There are some very exciting, maybe it's not the right word, techniques in this section as well. What's the domain of natural log of x? What's the domain of natural log of x? The hell with that. What is it? Any log is always just positives, right? So the domain of natural log of x, log base e, is just positives. You want to put positives in the natural log, in any log. So when I have this derivative written here, 1 on x, I know I said we do problem policy. So 1 on x looks basically like this. Okay? What's the domain of 1 on x? Is that right? All rows except 0. The domain of 1 on x is all rows except 0. But when you're taking derivatives of the natural log and you come to 1 on x, what you're asking is, what is the slope of natural log, right? So that information is contained here. The slope of natural log is right here, because that's where natural log exists, right? Natural log exists from 0 to infinity, not inclusive of 0. So when you take its derivative, you're going to come to this function. The values on this curve describe the slopes of this curve, right? So 1 on x is the only legitimate expression for the derivative as long as you cut out this side of it, okay? Because the natural log is only good from 0 to infinity. And so therefore its derivative, 1 on x, when that's where it came from, right? The homework problem didn't say graph 1 on x, right? Because then I would use the entire picture. It said, tell me the derivative of natural log. So what's the answer? 1 on x along what domain?
0 through 50.
That's right. Domain of 1 on x in that context would simply be the same domain you started with for the natural log. So it's not the entirety of the picture. It's not the entire function 1 on x. Okay? No big deal, right? Number, too easy. Maybe not. We'll do number 9. It's the first, I guess, real problem. So they're going to ask us the derivative of a logarithm and an applicable domain. Number 9 has for us y equals ln x squared. It says find the derivative of ln of x squared and an appropriate domain. Give the interval on which the result is valid. So that's why I mentioned what I mentioned a second ago.